At the farthest edge of our solar system, beyond the orbits of the planets, beyond Pluto, beyond even the frozen reaches of the Kuiper Belt, lies a realm so distant, so vast, and so mysterious that we've never seen it. Not once, not directly. We call it the Oort cloud. It is the final frontier of the sun's influence, a spherical shell of icy bodies, stretching halfway to the nearest stars. And yet, despite its size, perhaps trillions of miles across, we have no photographs of it, no confirmed sightings. No spacecraft has ever visited. Not even our most powerful telescopes have caught a glimpse. It is invisible, and yet we're sure it's there. Why? What is the Oort cloud really made of? How do we know it exists? And why has one of the largest structures in the solar system remained completely hidden? This is the story of a ghostly shell at the edge of everything we know, the invisible frontier of our solar system. When we think of the solar system, we usually picture the planets, Mercury to Neptune, orbiting neatly around the sun like clockwork. But that's only the inner sanctum. Beyond the planets lies the Kuiper Belt, a flattened ring of icy debris, home to dwarf planets like Pluto, Haumea, and Makemake. Even farther out is something stranger, a hypothetical sphere of icy objects, forming a vast cloud around the sun in every direction. That's the Oort cloud. It's not a disk. It's not a ring. It's a shell, a sphere of debris extending from roughly 2,000 Australian dollars to 100,000 Australian dollars from the sun. 1 AU is the distance from Earth to the sun, about 150 million kilometers. To put that in perspective, the Voyager 1 spacecraft, humanity's most distant probe, has been traveling for nearly 50 years. It's only around 160 Australian dollars from Earth. That's still thousands of times closer than the Oort cloud is believed to begin. The Oort cloud is not just far away. It is almost unimaginably far away. And that's part of why we can't see it. So what exactly is out there? The Oort cloud is thought to contain billions, maybe even trillions, of icy objects, each between a few kilometers and a few dozen in size. These are leftovers from the early formation of the solar system, primordial building blocks of comets, made of water ice, methane, ammonia, and rock. But these objects are tiny, cold, and dim. They reflect very little sunlight, and at such extreme distances, the sunlight they receive is minuscule. A typical Oort cloud object gets less light than a street light does from a candle 10 kilometers away. They don't shine. They don't glow. And from Earth, they're too far and too faint for our telescopes to detect. Even the James Webb Space Telescope, capable of seeing the most distant galaxies in the universe, is not designed to image these ghostly remnants in our own backyard. They're effectively invisible, not because they don't exist, but because they leave almost no trace. So how do we know they're there? The Oort cloud was first proposed in 1950 by Dutch astronomer Jan Oort, based on a puzzle. Why do some comets seem to come from all directions, not just the plane of the solar system? Short-period comets, like Halley's Comet, come from the Kuiper Belt. Their orbits are predictable and relatively flat. But long-period comets, with orbital periods of thousands or even millions of years, come in from random angles, sometimes from above, sometimes from below, sometimes from deep space. These comets aren't born near the planets. They're falling in from somewhere far beyond. Oort theorized that they must originate from a vast, spherical reservoir of icy bodies, gravitationally bound to the sun, but loosely, easily perturbed by passing stars or galactic tides. Every so often, one gets nudged inward, falling toward the inner solar system, where we see it briefly as a glowing tail of ice and dust. Then it disappears again for millennia. These comets are the messengers, hints of a vast population that lurks beyond our sight. Without them, we might never have suspected the Oort cloud existed at all. There are four big reasons the Oort cloud remains invisible. Distance. Even its inner edge is thousands of times farther than Pluto. That distance dims the already faint light these objects reflect. Size. Individual objects in the Oort cloud are small, mostly a few kilometers wide. That's like trying to spot a frozen marble from across a continent. Temperature. These objects are among the coldest in the solar system, just a few degrees above absolute zero. They don't emit infrared radiation in amounts we can easily detect. Density. Though it may contain trillions of objects, the Oort cloud is incredibly sparse. Each object is separated by vast distances, maybe tens or hundreds of millions of kilometers. There's nothing to form a visible structure. In short, it's like a fog of dust in the dark, except each speck of dust is the size of a mountain and hundreds of millions of miles from its nearest neighbor. Even with our best instruments, it's like looking for a single snowflake in the middle of Antarctica at night during a blizzard from the moon. Right now, we have no spacecraft capable of reaching the Oort cloud in any reasonable time. The Voyager 1 and Voyager 2 spacecraft, launched in 1977, are traveling at about 17 kilometers per second. Even at that speed, they won't reach the inner Oort cloud for another 300 years. And the outer edge? That could take 30,000 years. To explore the Oort cloud directly, we'd need propulsion systems far beyond current technology. Nuclear drives, solar sails, or perhaps even fusion propulsion. Until then, our only visitors are the comets. But every time one arrives, a sudden streak of light in the night sky, it brings with it a whisper from that dark, distant realm. You might wonder, if we can't see it and we can't visit it, why does the Oort cloud matter? Because it's a time capsule. The icy bodies within it have likely remained untouched for billions of years, preserving the original chemistry of the early solar system. They hold clues to how planets formed, where water came from, and even how life may have started. Some scientists believe Earth's water, and perhaps the organic compounds that seeded life, were delivered by early comets from the outer solar system. And the Oort cloud is full of them. It's also a boundary marker, the edge of the sun's gravitational domain. Beyond it lies interstellar space, the territory between stars. Understanding the Oort cloud is understanding the outermost limits of our cosmic neighborhood. Some researchers think the Oort cloud may have two parts. The inner Oort cloud, or Hill's cloud, denser, closer, and perhaps the source of most long-period comets. The outer Oort cloud, stretching out toward 100,000 Australian dollars or more, where the sun's gravity finally fades into the interstellar void. It may not be a clean shell at all, but a layered, complex, and dynamic region shaped by billions of years of interactions with other stars, galactic tides, and even passing molecular clouds. It could be that other stars have their own Oort clouds, and sometimes, when stars pass close together, their clouds mix, trading comets between systems. In that sense, the Oort cloud might be not just a barrier, but a bridge. So yes, the Oort cloud is invisible. We can't see it with telescopes. We can't touch it with spacecraft. We can't photograph it like Saturn's rings or Jupiter's storms. And yet, it's there. Every long-period comet we observe is a silent witness to its presence. Every icy nucleus, a relic of formation. Every tail of dust and vapor, a signature from a world on the edge. The Oort cloud is invisible, but it's not unknown. It waits in the dark, surrounding us like a vast, ghostly halo, marking the limits of the sun's reach and the beginning of everything beyond.